Welcome to Auto 155, Electricity and Electronics 1. My name is Tony DeBlasi, and in this lecture, I will be covering cranking system diagnosis and service. This is part 1 of a 2-part lecture based on Chapter 53 from the Automotive Technology Principles, Diagnosis and Service, 6th edition. For additional information on this topic, please read this chapter and refer to the PowerPoint found in the course content folder. Please note that there are both audio and visual lecture attendance codes scattered throughout this lecture. Please write these codes down as you see and hear them. At the completion of this lecture, you will be required to go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture. The following is an overview of the objectives covered in this lecture. I will explain the procedure to troubleshoot a starting system problem. I will discuss how to perform a voltage drop test on the cranking circuit. I will discuss how to perform control circuit testing, starter amperage testing, and determine the necessary action. I will describe the procedure to remove a starter motor. I will explain starter motor service and bench testing. I will describe the procedure to install a starter motor, and I will describe how to ensure proper clearance between the starter pinion and the engine flywheel. The information found in this chapter will help you prepare for the ASC Electrical Electronic Systems A6 Certification Test Content Area C. As far as our overview goes, obviously, we want to make sure that all of the components are working correctly for proper operation. We want to check them all. A lot of the times when you're doing starter diagnostics, it's easy to focus on the starter, but a big part of the cranking circuit is the battery. So we want to, the battery is there because of the starter. In other words, the CCAs of the battery are what they are so that the starter can pull from it. Ultimately, that's it, the largest load in the system. So we cannot overlook the battery when we're checking the starting circuit. So you'll hear the battery come back again. We'll be discussing that. So first off, when I get a vehicle that I have to check, I'm going to verify the customer's concern or verify the complaint. I'm going to duplicate the problem, in other words. I want to see what it is. Not just if someone says they got to replace something, I'm not just going to go replace it. I'm going to check it. So that's step 1. Step 2 is a very thorough visual inspection of the battery connections, battery cables, any type of acid. I'm looking for hold down, basically the 5 battery performance factors. Step 3 is I want to test the battery's condition. So I don't want to just check it visually. I also want to check it. I want to check its voltage. I want to test it for its CCAs. And the next thing I want to do is I want to check the control circuit. In other words, the switches, the neutral safety switch. I want to check any relays. I want to check any external solenoids, right down to the solenoid on top of the starter. I want to check all the control side before I get to the actual motor. The 5th thing that I want to do is I want to check the voltage drop of the starter circuit. Now, you'll be doing that over sections, or basically over sections. You'll be doing voltage drops for wires. You'll be doing voltage drops across switches. But I like to also start by doing a voltage drop across the battery terminals. So when I put my multimeter on the battery itself, if it says, 12.6, ultimately anything more than 12.4, if I have 12.4 to 12.6 volts at rest, if I go to crank the starter over, remember, I don't want that voltage to drop below 9.6 volts. That's the first key thing that we want to do. So I begin there, and once I've done that, once I've started there, then I like to actually check the wiring itself. Before we dive into the steps and we start voltage drop testing, one thing that can throw you off is if you have a vehicle with an anti-theft system problem or a theft deterrent lamp indicator on, if the vehicle's anti-theft light is flashing, that could indicate that there's either a problem or the vehicle is in immobilized mode, which means the vehicle's starter won't engage. It could also mean that the fuel and ignition systems might be turned off. And this is by design. In other words, the owner of the car, or the car believes that the owner has locked it down and secured it. When I have a vehicle with a suspected anti-theft system fault or some type of system that's acting up, what I want to do is try to disengage it or reset it. And for most factory security systems, to do this, you want to make sure that all of the doors are closed, and that includes the hood and any cargo areas or rear hatches or deck lids. Everything's closed. Obviously, I'm standing outside of the vehicle. I will hold the key fob in my hand, and I will cycle the doors from locked to unlocked. I'll do it a few times so I can actually see and witness the locks locking and unlocking. Like I want to hear the clicking, and I want to end up on unlocked. And then I will attempt to start the vehicle. This trick works pretty well because you've basically sent a signal to the body control module saying that you've disabled the security system. The other thing you can try is you can physically move the key. If it has a lock cylinder, you can put the key in the lock cylinder and cycle it back and forth. Sometimes that will also shut off the security system. I've done that in some cases on every potential or possible lock cylinder on the car, not just the driver's side door. So those are tips you can try, and oftentimes that will fix the problem. Now, as a quick recap on voltage drop testing, remember, voltage drop tests are used to identify areas of unwanted resistance in a live circuit. So we need current to be flowing. So as we go to crank the starter over, we want to test the entire conductive path. So I want to be able to crank the starter. I don't want the engine to start. So I'm going to disable either the ignition or the fuel injection or the fuel system. One of the things I'm going to recommend to everybody is if it has a fuel relay, pull the relay. One thing that, I mean, I know this says disable the ignition or the fuel. The problem is if you unplug an ignition coil or an ignition circuit, or you unplug a cam sensor or something like that, there's a potential that the fuel injectors can still spray fuel into the cylinder. So what you've ended up with is you've loaded that cylinder full of fuel. I would much rather disable the fuel system before the ignition system. Just a rule that I like to go by. So by doing this, you will allow the starter to crank the engine, but the engine will not start. Now in a moment, I'm going to show you a couple of examples and diagram of a multimeter and starting circuit. And we're going to check the wiring from the battery to the starter. We're going to check across the starter solenoid. We're going to check across the starter's ground. We're going to check also the negative side or the ground side of the battery as well. Before we do the actual cable testing though, one of the things I would recommend is check at ground zero. So in other words, in this example, the red lead of the multimeter, the positive lead, is resting directly, firmly on top of the actual post of the battery, while the black lead is on the terminal. So if there's any bad connection here, or let's say excess resistance that's built up, it will show. So we want to do this during crank. Now you'll notice that it says we're looking for a tolerance up to 200 millivolts or 0.2 volts. That should be, it should be anything under that number as a rule here at the actual terminal. Chapter 53, lecture code question number 3. Please write this down. 62354. Once again, that is 62354. Please write this down. The next place that we're going to be testing is between the battery's positive post and the BAT or B nut of the starter solenoid. So essentially the cable that is the positive cable that runs directly to the B post, we're going to verify that it does not have unwanted resistance. So we'll place our multimeter between those 2 points, and when we crank the engine with the fuel or ignition system disabled, we want to make sure that we're not seeing a number that is greater than 200 millivolts, just like at the terminal. So each one of these sections, we're looking for a tolerance of up to 200 millivolts or under that number. Next, we're going to be testing across the solenoid, so the switch, the actual switch. So between the B nut and the M terminal. Once again, we're looking for that magic number of under 200 millivolts. Lastly, we're going to be checking the battery's ground connection. If we crank this engine over, we don't want to see the 200 millivolts or 0.2 volts again. One other test I might do is put my multimeter on the actual case of the starter itself and on chassis ground, and I'll do that same test too. I know that's not included in this diagram here, but I'll do that same test. At this point, I want to play a clip from Films on Demand to show this in action.
Voltage drop tests can quickly locate a part with higher than normal resistance. They provide an easy way of checking circuit condition. You do not have to disconnect wires or components to check internal resistance or voltage drops. Crank the engine with the voltmeter connected to the section of the circuit to be analyzed. Generally, you do not want over about a 0.1 to 0.2 volt drop across any electrical connection. For example, if you connect the voltmeter from the battery to the starter input terminal, you will check all connections between the two test points. Your voltmeter should show only about a 0.5 volt drop with the engine cranking. A higher voltage drop would show a poor electrical connection. You would simply move your test leads inward to isolate and find the source of the high resistance problem.
Chapter 53, Lecture Code question number 5. Please write this down. A is in apple, B is in boy, 150. Once again, that is AB150. The next thing we can discuss beyond voltage drop testing is we could have a control circuit side. So let's say that we don't have a crank at all. Let's say that there's no sound or a clicking sound. That could be an open or a break anywhere in the control circuit that prevents the operation of the starter motor. So the things that we can check or test, we can check the neutral safety switch or the clutch switch, as discussed last week. Those are necessary so that we don't accidentally start the vehicle while the vehicle is in gear. So if they're faulty, they may not allow the actual starter to engage, period. So we can test for those. We can also check if there's a fuse. If there's a fuse down to the starter, we can check that. That's easily done right at the fuse panel. There could also be fusible links that we can test. We can look for opens at the actual ignition switch itself while in the crank position. So we could test for that. If there's a starter relay or let's say a separate solenoid, like a remote solenoid, like on some Fords, we can test that as well. Some starters have a module. We can make sure that it has good grounds and powers if it obviously is equipped. And as discussed earlier, it could be part of the control side could be actual anti-theft controls, the immobilizer. So we'll take this moment to play another clip from Films on Demand to go over some basic components to be checked when we're checking control side circuit testing.
A misadjusted or bad neutral safety switch could keep the engine from cranking when the key is turned to start. You may have to wiggle the gear shift to get the engine to crank or place the shifter in neutral. Most neutral safety switches are adjustable. With the transmission gear shift set in park, loosen the bolts on the switch. With the key held to start, rotate the switch until the engine cranks. As soon as the engine cranks, tighten down the bolts that secure the neutral safety switch. Then recheck the adjustment by moving the shift lever into park, neutral, and the various gear positions while starting the engine. A faulty ignition switch can also prevent engine cranking. The ignition switch may not be feeding current to the starter solenoid. A test light will quickly tell you if current is being fed to the solenoid whenever the key is turned to start. To replace a modern column-mounted ignition switch, remove the plastic steering column covers to gain access to the switch. In some cases, the steering wheel must also be removed to completely remove the plastic covers. Use tamper-proof Torx to loosen the retaining screws. Replace the switch and tighten the screws. Reassemble the plastic covers in reverse order. To replace an older column-mounted ignition switch, a small hole must line up with the pin or rod leading from the ignition key mechanism. Fit the rod into the hole, then reinstall the fasteners that secure the ignition switch to the steering column. Slotted holes in the ignition switch allow you to adjust the switch. Hold the key to start, then slide the ignition switch until the engine cranks, then tighten down the screws. Fusible links are often used in a starting system. If you forgot to disconnect the battery, they protect against serious electrical damage if you accidentally short a hot wire to ground. A fusible link is basically a large gauge wire with a small gauge wire linked in the middle. The small gauge wire will overheat and burn if you accidentally short the wire to ground. The short will produce excess current flow, which heats the link and burns it in half. When the link burns in half, it protects the rest of the car's wiring from major damage. On today's systems, a large high-current fuse is often wired into the charging system. A major short can blow the fuse. Check for a blown fuse or a fusible link if power is not reaching major sections of the car's electrical system.
This concludes the Part 1 lecture for Chapter 53, Cranking System Diagnosis and Service. For additional information on this topic, Please read this chapter and refer to the PowerPoint found in the course content folder. Now that you have completed this lecture and you have written down the online lecture attendance codes, please go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture.